that you can see my screen now. My name is Erika Matuschek, and I work at the EUCAST Development Laboratory, also called EDL. We are located in Växjö in Sweden. And today I will give you an update on what we are working with right now. Our main task at the EDL is to develop and maintain EUCAST methods. We do a lot of lab work ourselves, but we also do many projects in collaboration with other laboratories, both in Europe and in other non-European countries. We could say that we have three major tasks within this topic. One is to develop criteria for new antimicrobial agents. And almost every year when we publish a new breakpoint table and a new QC table in the beginning of January, we have new agents added. Recent agents are, for example, cefiderocol, imipenem relebactam, and the meropenem vaborbactam. We also work to develop methods and breakpoints for organisms which don't have methods and breakpoints. And almost every year we add one or two of those species as well. And I will give you some examples of what we are working with in that area today. We are also constantly working to improve the existing breakpoints and the QC criteria that we have by provoking the system, by picking up problems and troubleshooting. A large part of our work is also to function as a support unit to clinical laboratories using our breakpoints and methods. We have several educational activities, sometimes like this, but it could also be courses with practical parts, which of course hasn't been done during the pandemic. And another part or work that we do is to evaluate AST materials for some important agents or some important systems where we might have signals that there are problems. And those evaluations sometimes result in a warning on the EUCAST website where we can warn that these materials have quality problems. But we can never evaluate all AST materials on the market. So the fact that there is no warning doesn't mean that there might not be problems. I will start with two examples of work we are doing right now for organisms without methods and breakpoints. And the ones I will present today are anaerobes and Vibrio species. We have worked several years to improve anaerobe antimicrobial susceptibility testing. One part is to develop a new reference methodology for MIC testing. You might know if you go to the EUCAST table, it's a bit vague that there is no reference method for anaerobes, but the generally accepted method is agar dilution. The American committee, CLSI, has an agar dilution method which is based on Brucella blood agar as the medium. What has been done now is many comparisons. If you perform agar dilution on Brucella blood agar and also fastidious anaerobe agar, FAA. And that work has been done at the UK Reference Laboratory for Anaerobes in Cardiff in collaboration with us at the EDL. The EUCAST Steering Committee is also performing a review of the MIC breakpoints. And the breakpoints for anaerobes are old. They haven't been reviewed for some time. And now we have also more data with species-specific MIC distributions and look at Bacteroides per se, Privotella per se, etc. So there will be more species-specific and some different MIC breakpoints coming out from this work. And actually for several years, we have worked at the EDL in collaboration also with other labs to develop a disk diffusion method on FAA, fastidious anaerobe agar, for rapidly growing anaerobes. And for this method is only developed for selected species. So it's not fine to by yourself just define what is a rapidly growing anaerobe. So this method is only for 5 selected species and for some important antimicrobial agents. Our plan is to add additional agents further ahead. The species that we have selected are Bacteroides species, Prevotella species, Clostridium perfringens, Fusobacterium necrophorum, and Cutibacterium acnes. The disc diffusion test is performed on Fastidious anaerobe agar, and we have used agar dilution on FAA as our reference MIC method. And that reference, the MIC method, is in turn calibrated to the reference method on Brucella agar with very similar results. One of the advantages, or one of the main advantages of using FAA for AST of anaerobes is that it supports growth much better than the Brucella agar. It's very obvious when testing Fusobacterium necrophorum, which grow much better on FAA compared to Brucella agar, and that affects both zone sizes and MICs. The agents that we have selected for this first part of the development is benzalpenicillin, piperacillin tazobactam, meropenem, vancomycin, clindamycin, and metronidazole. And we can say that we have 3 major phases and steps in this development. First of all, we have done a lot of work to investigate which parameters affect the results for the disc diffusion test. We have looked at media. We have compared Brucella blood agar to FAA, but we have also compared FAA agar from different manufacturers. We have looked at the inoculum size. We have looked at the method for achieving an anaerobic environment if you use a workstation or a box, which we sometimes call it, an anoxomat, or jars with gas generating systems. We have looked at the incubation time and also the incubation temperature. And all that work is presented in a paper that has been accepted for publication in CMI, and it's available online, and you can see the reference here. After that, we have performed at the EDL in collaboration with a lab in Cardiff, where they performed all the MICs. MIC zone limit correlations for the 5 selected species. And also in this work, we have variation in FAA agar source, incubation method, etc. And what is going on right now is that we are performing a field trial with 16 laboratories in Europe. The first part is finalized, where these labs tested the same collection of 35 isolates with known MICs. And the second phase is just going to start, where these same labs will now test local isolates. So the final method for disc diffusion of anaerobes on FAA is this. The media should be Fastidious anaerobe agar with 5% mechanically defibrinated horse blood, no other additives. The agar depth of the plates must be 4 millimeters, plus minus 0.5 millimeters, as for all AST tests. It's very important to dry the plates prior to inoculation. We recommend that for MHF plates to the media used for other fastidious organisms in the EUCAST disc diffusion test, but we have observed that it's even more important when using FAA for anaerobes to dry the plates. Plates can be dried, produced in-house, but they can also be purchased commercially from some sources. The inoculum should be McFarland 1, and incubation should be performed at 35 to 37 degrees in an anaerobic environment for 16 to 20 hours. It's not allowed to prolong incubation. That will result in significantly different zone sizes, and all the breakpoints that will be published and the QC criteria are set for 16 to 20 hours of incubation. For some of these organism-agent combinations, it is a little bit difficult to read zones, and there are some specific reading instructions, and we have also now produced a reading guide specifically for anaerobes to try to help to explain in detail how to read these zones. I will now show a few examples of results from the anaerobe field trial. The labs tested both QC strains, one gram-negative strain, a Bacteroides fragilis strain, and one Clostridium perfringens strain. And I have just chosen 2 examples here. This is Bacteroides fragilis with meropenem. And the graph that you see now, that is all the data that we have from testing at the EDL. And the colors of the bars correspond to different FAA manufacturers. And then you can see that from that data, we have established a range of 32 to 39 millimeters with a target value of 35 to 36. And then if we compare our data with the data from the field trial, in this graph, the data from the EDL is in light blue and the data from the field trial in dark blue. You can see that it actually fits very well with the range that we have established. And the second example is for Clostridium perfringens, ATCC 13124 and clindamycin. We have a very tight distribution here, 20 to 26 millimeters. And when we add the data from the field trial, most of it fits very well with our data. But you also probably see that there are some outliers at 16 to 19 millimeters where there are 2 small zones. And we suspect that that is due to haze or fuzzy zonages when reading. And we have now spent a lot of time to give feedback back to all these labs. And they will now test again the QC strains when they start to test clinical isolates. So we think that by troubleshooting and education, we can avoid those results out of range there. If we then look at the results for the clinical isolates, I have also chosen a few examples. This is for Bacteroides species and meropenem. And the data that you see now, the graphs to the left, show our reference data from the EDL. The upper graph shows 170 clinical isolates of Bacteroides tested with disc diffusion, and for 50 of these, we have agar dilution MICs on FAA. And the green colors here correspond to susceptible MICs, and orange and red to resistant ones. These colors are according to new proposed breakpoints, which are not completely final. But if you don't recognize them, it's just because these are the ones that are suggested for the revised breakpoints. In the lower graph here, you can also see for Bacteroides fragilis only, which were 112 isolates out of the 170, that the disc diffusion test can separate out the isolates which are positive for the CFIA gene. If we then look at the results from the field trial, it looks pretty similar. So the upper part graph here shows again zone diameters versus MICs. And you can see that the one difference between the field trial data and the EDL data is that there are much more results in the area just below the wild type, 20 to 28 millimeters. So we have intentionally included more difficult isolates here. But the main picture is quite similar. The isolates with really high MICs end up at 6 millimeters, and there is a nice correlation between the MICs. The last graph one here in the lower right corner shows every isolate. There were 12 isolates of Bacteroides in the field trial collection, how these vary in zone sizes. Each of the isolates has a separate color here. And when we have analyzed the data from the study, we have looked at each of the isolates specifically to see if we have more variation for some and where they are deviating results. Another example is here for Prevotella species and benzyl penicillin. And here you can see that we have FAA MICs for all the 50 isolates tested. Here we have isolates that are susceptible, the green bars, the ones that are very resistant at 6 millimeters, and then a few just above with the 6 millimeters. And when we look at the study isolates, it looks very similar and a very good reproducibility for the different isolates tested. Clostridium perfringens and clindamycin. Here we have 3 distributions, more or less, one susceptible, one with low level resistance, and one with high level resistance. And for the study isolates, we get a very similar distribution. So our conclusions are that the results from the field trial confirm that the disk diffusion method for anaerobes work. And this was even though we know that some participants found the zones difficult to read, but still in the end, it looks really good when we put all the data together. The data from the field trial will be used or has been used already to improve our method documents, how we describe the method, the more improved reading guide, etc. And also it will help us to set robust zone diameter breakpoints for anaerobes. This week we have published the method, which also includes QC criteria for those 2 strains and an additional strain, which is an aero-tolerant Clostridium perfringens, which we recommend that you use to check the anaerobic environment of your incubation. That is available on the EUCAST website. You go to AST of bacteria and disk diffusion methodology. And there are no breakpoints yet, but you will find the method there and you can start to produce plates or buy plates and practice on the QC strains to be ready when we publish the breakpoints in 2022. So another example is Vibrio species, which we are also working with right now. For Vibrio, we have selected, or the EUCAST steering committee has selected 5 clinically relevant species. Algoniliticus, Cholera, Fluvialis, Parahemolyticus, and Vudniticus. The method is not complicated here. It's just standard millihinton broth for broth microdilution and standard millihinton agar for disk diffusion. And these breakpoints will be published in the next version of the breakpoint table, so for January 2022. For Vibrio, we have tested some more agents, beta-lactams, fluoroquinolones, macrolides, tetracyclines, and trimethoprimsulfamethoxazole, and some discs that will be used as screening discs only. And I will show you just some results, some examples of results for Vibrio. So in these graphs, we have aggregated all the tested isolates together. So here we have 233 isolates. They are tested on millihinton agar from 2 manufacturers in parallel. So it results in 466 correlates. And these are also, the colors correspond to the ECOF, which separates the wild type from the non-wild type, but also probably the likely breakpoints for Vibrio. So the first example here for piperacillin tazobactam, you can see that we have a very nice separation between the wild type and the non-wild type. So wild type isolates, the ones without acquired resistance mechanisms, form a nice normal distributions, and the non-wild type, the ones with acquired resistance mechanisms, end up on below that population. And you can also see the MIC distribution in gray bars in the smaller graph here, that it fits very well that we have a wild type and a non-wild type. For meropenem, we have 2 different populations, both with MIC and disk diffusion, but most of the MICs, as you see, are below 0.5 milligrams per liter, and they will probably be reported as susceptible, except for the ones here at 1 milligrams per liter. Ciprofloxacin, a little bit broader distribution, but still a very nice correlation between inhibition zones and zone diameters. And for ciprofloxacin, it will also be possible to use the p-floxacin disc to screen for resistance. And then we have a little bit of separation between the wild type and the non-wild type. And the last example is for trimethoprim sulfamethoxazole, where isolates are either quite susceptible or highly resistant with a nice separation. Some of these isolates do have some hazy growth within the zone, so there will be a specific reading instruction for Vibrio and trimethoprim sulfamethoxazole to read the outer zonage if there is hazy growth within zone. But if we don't do that, we have a very nice correlation between inhibition zones and MICs. I could also say that we test Vibrio cholera that are non-toxin producing at the EDL, and the CDC in the USA will help us to test a similar amount of toxin producing Vibrio cholera, just to see that we don't have any methodological problems there, that they can be tested too if you work in a facility with higher security. Then I will change to another subject and give you an example of where we have evaluated AST materials on the market. And this example is for benzyl penicillin gradient tests. And we looked specifically at Streptococcus pneumoniae, where it's very important to have a reliable benzyl penicillin MIC, especially in meningitis, but also if you are in the category, in the I category, between 0.06 and 2 milligrams per liter, and to make your correct interpretation. So we selected 57 Streptococcus pneumoniae, and 45 of them had benzyl penicillin MICs above 0.06 milligrams per liter. So this was a very difficult collection. You can see the MIC distribution at the end of the slide here. We used broth microelution in MHF broth, the EUCAST media for fastidious organisms, as our reference. And we looked at gradient tests from two manufacturers, E-test from bioMérieux and MTS from Liofilchem. And we tested them on agar MHF plates prepared with BBL and oxoid agar in parallel. And in this graph, you will see in the upper part, it's the results for the E-test, in the lower part, results for MTS. And the broth micro reference MICs here are in columns, and the test MICs from the gradient tests are in rows. And the green cells show MICs that are identical. So a perfect correlation, we would have all the MICs within the green boxes. We know that that's not possible, and we will always have to allow for some random variation. The yellow bars show MICs that are one dilution above or below the reference MIC. But if we look at the numbers of MICs that are above and below, you can see that the numbers of MICs below the identical MICs is much higher than the one above, and even more so for the MTS. So there is a systematic difference that you get lower MICs with the gradient test than with broth microdilution. The breakpoints, both for meningitis and for other infections, are shown as line here. And the red numbers show isolates that will be have an erroneous categorization with the gradient test MIC. So you can see that, for example, isolates with a broth microdilution MIC of 4 milligrams per liter, which should be reported as resistant also for indications other than meningitis. Most of the MICs will be reported in the I category with the gradient tests. So the results from this study resulted in a warning on the EUCAST website that we warned for, and that E-test and MTS systematically underestimate benzyl penicillin MICs for Streptococcus pneumoniae. And we have a specific recommendation that isolates with the gradient test MICs of 0.5 to 2 milligrams per liter should be checked with broth microdilution. And to help labs to validate their MIC methods for benzyl penicillin, we have developed a panel of 10 Streptococcus pneumoniae with varying beta-lactam susceptibility, which is now available from the Swedish culture collection CCUG. And reference MICs are available from the EUCAST website. So you can buy the package of the 10 strains from CCUG, test them, and then compare to the reference MICs that you find on the EUCAST website. And we have continued to develop similar reference panels, and we are now working with Pseudomonas aeruginosa. And we have a collection of 9 well-characterized isolates with varying susceptibility to different relevant antimicrobial agents. BMD has been performed many times, both at the EDL and in 2 external laboratories, and we are now waiting for genotypic results from whole genome sequencing to even further characterize these isolates. So this will also be available later on from CCUG, and we plan to develop similar panels also for other organisms. So that was my last example for today, and I would like to end by thanking all the clinical laboratories that participate in our studies, the ones that contribute with data and or isolates, because we could never do this without you. And of course, also everyone working at the EDL and collaboration with the EDL to perform these studies. And just going back to what I said in the beginning, that one of our major tasks is to work as a support unit to clinical laboratories using our methods. So if you have any questions or problems, you are always welcome to come to contact us, and we will do our best to help you to troubleshoot.
Thank you very much, Erika. So I think, did you have any Mentimeter questions?